Hi, thanks for joining me today. I'm going to be kind of solving a quartic equation. It's kind of solving, not solving. You'll see what I mean as we go along. So C is a positive number, and we have this quartic equation here. X to the 4 plus 2cx squared minus x plus c squared plus c is 0. And we're told that this has exactly one positive real solution for x, that is. And from this information alone, we just want to find the value of C. So supposedly there's only one positive value of C such that this equation here can have one positive real solution. We need to find that value. If you want to have a go at this problem, pause the video now and give it a go for yourself. And I'm going to dive straight into a solution. Okay, so the solution for this, I think, is either you'll love it or you'll hate it. I don't think there's a nice in between. So I'm just giving you an advanced warning. So the trick here is to kind of just fiddle about with this equation. So what I'm going to do is group these three terms together, plus 2cx squared plus c squared, and then these remaining terms, c minus x, I'll keep on the end, equals 0. And the reason I want to group these three together is, hopefully if you just stare at this, you can see that this is just a nice perfect square. It's x squared plus c all squared. And then if we bring this c and x to the other side, we get x minus c. So x squared plus c squared equals x minus c. And now what we're going to do is square root both sides. So we get x squared plus c, and then maybe you might think we need to put plus or minus here. But because this left-hand side is guaranteed to be positive, because x is real, when you square it, it's non-negative, and you add c is a positive number, this is definitely going to be positive, so we know that it's going to be the positive root here. So x squared plus c is root x minus c. And you might ask where we go from here. And here's the trick. What we're going to do is consider a function, I'll put this on the side here, f of x. And we're going to consider the function f of x equals x squared plus c. And now what we're going to do is try to find, and we're going to assume here x is positive, because remember we're only looking for the positive, well we're only told that there's a positive real solution, so we may as well restrict this function to positive values of x. So f of x is going to be x squared plus c, and x is positive, and so this condition here insists that this is an invertible function. And so if we look to find the inverse, so if we do f of x minus c equals x squared, and then square root both sides, we get this, and I don't have to worry about plus or minus again because x is positive. I get that the inverse of this function is just root x minus c, which coincidentally is what we have here. So essentially we're solving the equation f of x equals f inverse of x. And there's a very, very nice trick for this. So remember, when you are looking to solve an equation or a function equals its inverse, remember that when you sketch these two graphs, they're reflections of one another in the line y equals x. So if I draw it like that, so x squared plus c might look something like that. So it's a parabola, normally like that, but we don't have the left half because x is positive. The y-intercept there is c, and then this will look something like that, where this is c. So this is f inverse x, and this is f of x. Now, the thing is, we're told that this equation here has exactly one positive solution. And the way I've drawn it here, it looks like there's no positive solution. So maybe I need to switch or change the value of c, or at least visually change that value. And so maybe I make c a bit smaller. So if I make c somewhere down here, and then the parabola might look like that, and then the inverse function might look something like that. But you see, we've got 2 points of intersection now, one here, one here. And then we go, okay, so in order for us to have exactly one solution, both these curves have to be a tangent to this line y equals x. So it'd end up looking something like this. So if c is there, the inverse function would look something like that. And this would look something like that. Oops, that's supposed to be touching there. So they're both supposed to be tangents to this graph, to the line y equals x, and this would give us the one solution, exactly one positive solution for x, and obviously these guys will never intersect again, they're going in completely different directions. And so this is the value of c that allows them to have exactly one positive solution. Well, the question is, how do we work out this value of c? Well, we're going to use the fact that this parabola here is a tangent to the line y equals x. So this parabola is y equals x squared plus c, and if we set it equal to x, which is this y equals x line, we know that this equation has exactly one solution. So I can bring that x onto this side, and this quadratic equation has exactly one real solution, so we can just look at the discriminant of it and set it equal to 0. So 1 squared minus 4 times 1 times c equals 0, and so therefore c must be a quarter. And that there solves our problem. So in order for this equation at the top here to have precisely one real positive solution for x, we require c to be a quarter. A pretty nice problem, and as I said at the start, I'm not sure whether you'll like this solution or you won't like this solution, because it's kind of like, well, how would you think to do this? I think it's quite neat, and I think if you played about with this, maybe you could spot this if you got to something like this. I think the perfect square thing is quite nice to do. Square rooting, somewhat intuitive. But I'm not 100% sure if I was seeing this for the first time, whether I'd appreciate it and go, yeah, I could reproduce this in the future. It's not really that obvious. But I think it's an interesting solution nonetheless. Let me know in the comments down below what you thought. If you have enjoyed this video, please do give it a like, and if you're new to the channel and enjoying my content, please do subscribe. It's a free way to help support the channel, and if later down the line you decide, you know what, you're not enjoying the content anymore, you can always unsubscribe. Thanks for watching. I'll catch you in the next one. Have a great day.